Hi, welcome to today's class. Today we are going to learn about inductive proof from the subject Theory of Computation under the chapter Automata and Regular Expression. Inductive proof is also called as proof by mathematical induction. It consists of three steps: basis, induction hypothesis, inductive step. In basis, we apply the lowest possible value to the left hand side as well as right hand side, and we try to prove left hand side and right hand side are equal. This is the initial step. In induction hypothesis, we assign n equal to k and assume the result is true. Since this is a hypothesis, we assume the result is true. In inductive step, we assign n equal to k plus 1 and we check whether left hand side is equal to right hand side by substituting the results obtained in the induction hypothesis. For example, prove by induction on n that summation I equal to 0 to n I equal to n into n plus 1 by 2. So to prove this by induction, we need to follow these three steps: basis, induction hypothesis and inductive step. Initially we need to assign very lowest possible value, and second we assign n equal to k, and in inductive step we assign n equal to k plus 1. Let's substitute these values here. In this equation, in the given question, I equal to n into n plus 1 by 2. We need to prove this, right? Here the lowest value given is 0, but we cannot use this value. If you use, then we can obtain only directly 0 in both sides, right? So instead of that, we go with I equal to 1. So the lowest possible value for this equation is I equal to 1. So let's assume n equal to 1. So this implies left hand side is equal to 1. Here we are applying n as 1, right? So I is equal to 1. In right hand side, we are substituting this value, n is equal to 1. So 1 into 1 plus 1 by 2 is equal to 1 into 2 by 2 is equal to 1. So we proved that left hand side, this one and this one, both are same. Then we need to perform the induction hypothesis. Left hand side equation is summation I equal to 0 to n, which can be written as 1 plus 2 plus 3 plus 4 plus up to etc. n. Here we need to assume equal to k. Based on the induction hypothesis steps, we need to assign n equal to k. So we need to assign n equal to k here. So left hand side can be written as 1 plus 2 plus 3 plus up to etc. plus k. So this is left hand side. Let it be 3. So we need to use this result obtained in induction hypothesis to get the inductive step proof. We need to get the result here and we need to apply here to get our actual result. So right hand side, n into n plus 1 by 2. So substitute n equal to k. This implies k into k plus 1 by 2. So this is the right hand side. So we assume left hand side is equal to right hand side since this is hypothesis. Okay, so assume three is equal to 4. Left hand side is equal to 4. Implies 1 plus 2 plus 3 plus up to etc. plus k is equal to k into k plus 1 by 2. Let it be 5. So next is inductive step. Here we assume n equal to k plus 1. The left hand side is summation I equal to 0 to n. I can be written as 1 plus 2 plus 3 plus up to etc. k. Here the previous value of k is k minus 1, right? Here we are ready. The previous value, each value is incremented. So previous value is decremented. So previous value of k is k plus 1. Here we are assigning k n equal to k plus 1, right? So let it be n to understand properly. So we are assigning n equal to k plus 1. And so it becomes k plus 1 and this becomes k plus 1 minus 1. So it can be written as 1 plus 2 plus 3 plus up to etc. k plus k plus 1, right? So in left hand side we are writing as 1 plus 2 plus 3 plus up to etc. k plus 1. Here we already know that 1 plus 2 plus 3 plus up to etc. k is equal to k plus 1 by 2 by induction hypothesis. So we are going to substitute this equation 5. So 1 plus 2 plus 3 plus k is equal to k into k plus 1 by 2. We have substituted this value plus the remaining value of k plus 1. So we have substituted equation 5. Again, this equation can be written as k into k plus 1 plus by 2 into 2 into k plus 1 by 2. So which is equal to k into k plus 1 plus 2 into k plus 1 by 2. Here k plus 1 and k plus 1 is common, so we take it outside. So k plus 1 into k plus 2 by 2. This can be written as k plus 1 into k plus 1 plus 1 by 2. So which is equal to, okay, mark this as equation 6. Let's get the value for right hand side. So assume n equal to k plus 1. Right hand side is n equal to n into n plus 1 by 2. So when substituting k equal to 1, k plus 1 into k plus 1 plus 1 by 2. So this is equation 7. Here equation 6 is equal to equation 7. So we have proved the induction. Thus proved. Let's recall it again. To prove the induction, we need to follow 3 steps: basis, induction hypothesis, and inductive step. In basis, we need to apply the lowest possible value to n. In induction hypothesis, we apply n equal to k. In inductive step, we applying n equal to k plus 1. So in our example, summation I equal to 0 to n I is equal to n into n plus 1 by 2. Initially we applied for the basis, we apply n equal to 1. So this implies left hand side is 1, I equal to 1, and right hand side is 1 into 1 plus 1 by 2, which is equal to 1. So we proved left hand side is equal to right hand side. In inductive hypothesis, we applied n equal to k. So this implies we need to apply n equal to k. Before that, we need to get this equation. So here I is given as I equal to 0 to n, which can be written as 1 plus 2 plus up to etc. k is equal to n into n plus 1 by 2. Here we are assigning n equal to k, so it's up to n. So we are substituting n to k and assuming left hand side is equal to right hand side. In inductive hypothesis, so k equal to k into, we are substituting n to k into k plus 1 by 2. In inductive step, the third step, we are assigning n equal to k plus 1. So this equation can be written as 1 plus 2 plus 3 up to k is equal to n into n plus 1 by 2. Sorry, this is n. So here we are substituting n equal to k plus 1. So this can be written, this equation can be written as 1 plus 2 plus 3 plus up to etc. k plus 1 is equal to k plus 1 into k plus 1 plus 1. We are substituting n to k plus 1 into k plus 1 by 2. So this left hand side can be written as 1 plus 2 plus 3 plus up to etc. The previous value of k plus 1 is k. So k into k plus 1 is equal to k plus 1 into k plus 1 plus 1 by 2. Here this can be 1 plus 2 plus 3 plus k can be written as k into k plus 1 by 2. How? From induction hypothesis we obtained 1 plus 2 plus 3 up to k is equal to k into k plus 1 by 2. We are substituting this value here. So k into k plus 1 by 2 plus k plus 1. So leave the right hand side. This is right hand side. This left hand side is equal to k into k plus 1 by 2 plus 2 into k plus 1 by 2. So we are taking the LCM, and which is equal to k into k plus 1 plus 2 into k plus 1 by 2. Since k plus 1 is common, we take it outside. So k plus 1 into k plus 2 by 2. So which can be written as k plus 1 plus 1 by 2. So this is equal to right hand side. Here we got the right hand side. So both are same, hence we proved the result.